Deep inside a restricted industrial zone stands a facility unlike anything in modern defense history. Here, scientists and engineers study the armadillo's natural armor-its layered plates, flexible shells, and shock-absorbing structure. Every detail is scanned with extreme precision, turning nature's ancient survival design into the blueprint for next-generation protective gear built for soldiers, explorers, and higher-risk responders. In the biomaterials lab, engineers analyze real armadillo scales under powerful microscopes. Each plate is mapped for density, curvature, and impact distribution. Researchers discovered that the animal's shell is strongest not because it is hard, but because it can bend and disperse force. This insight inspired a revolutionary hybrid, a flexible bioceramic armor that moves with the body while resisting crushing pressure and ballistic shock. A massive robotic chamber creates synthetic scales using nanoceramic powders mixed with advanced polymers. Laser sintering machines fuse the material layer by layer, forming tiles that mimic the armadillo's natural segmentation. Every tile is shaped with slight curvature, allowing it to shift and rotate subtly, absorbing force without cracking. Rows of these glowing tiles cool under controlled airflow before entering the structural assembly line. The core of the armor is built on a flexible mesh that behaves like living tissue. Sensors embedded inside the mesh track movement and pressure, adjusting stiffness in real time. When force is detected, the bioceramic plates tighten their formation, creating a temporary, rigid shield. When relaxed, they loosen to allow mobility. This adaptive response is the secret behind the armor's exceptional comfort and extreme protection. Next, the plates move into the bonding unit. Robotic arms rotate, align, and press each tile into place with micro precision. High-strength adhesives form molecular bonds, turning hundreds of small plates into one continuous protective surface. Unlike traditional armor, this system doesn't rely on single heavy slabs. Instead, it uses clusters of interlocking scales that behave like a living exoskeleton around the user's body. In the impact testing hall, giant mechanical hammers crash down on sample panels, delivering controlled strikes, simulating explosions, falls, and high-velocity hits. Slow-motion cameras capture how the bioceramic scales ripple, bending outward to diffuse energy. Instead of shattering, the plates distribute the force across the entire mesh. Engineers analyze every frame, fine-tuning thickness, spacing, and curvature for maximum survival probability. Ballistic weapons testing pushes the armor even further. Projectiles fire at varying speeds, angles, and distances. The plates respond with a remarkable defense pattern. Outer tiles absorb the hit, inner layers compress, and the mesh redirects shock sideways. The result is minimal penetration and drastically reduced blunt trauma. This multi-layered defense system allows the armor to withstand threats that traditional vests cannot endure. Temperature resistance is tested in extreme chambers. The armor must survive Arctic winds, desert heat waves, corrosive environments, and sudden thermal shock. Bioceramic scales resist melting and cracking even when exposed to intense flames. Cooling channels built into the mesh keep the wearer's temperature stable. This resilience ensures that the armor performs reliably in climate zones where ordinary gear quickly fails. Once verified, the armor enters the ergonomic shaping wing. Here, suit frames are molded to match natural body contours. Articulated joints are added for knees, elbows, and shoulders, ensuring free movement without exposing weak points. The final outer layer is wrapped in a lightweight tactical fabric that resists water, dust, and abrasion. By this stage, the armor feels more like advanced clothing than heavy protection. In the final inspection room, experts review every plate, sensor, stitch, and seal. Only flawless units receive the approval stamp. The completed armor suits are packed in secure cases and shipped to elite units, researchers, and specialized rescue teams. What began as inspiration from a small armored animal now stands as a breakthrough in human protection proof that nature still holds the world's most powerful designs. If you enjoyed this deep dive into the cutting-edge world of Armadillo Bio-Ceramic Armor, don't forget to hit that subscribe button. Like, share, and turn on notifications so you never miss a behind-the-scenes look at the world's most fascinating production processes. Right here on Production Insider.